Okay, let's start with this. So today we're going to present to you our project, which is related to electromyograph. So let's start with what is an electromyograph, or EMG for short. And we are a team of two. It's only me, Jesus Gael Granados Gonzales, and my partner who's down below me, which is Fernando Mendoza. So let's start. So what's an EMG? An EMG stands for electromyography. So this is a diagnostic tool which uses the electrical impulses provided by the muscles for them to be activated, and it sensors them in a way that it can be represented in a graphic way. So there are a few ways of doing so. One of them would be through needles, which would puncture the skin, or with electrodes, which will be placed only just on top of the skin. It depends on the procedure or the muscles that you want to check on. So what does it measure, right? So for example, we have right here an oscilloscope. As in an oscilloscope, what measures is the electrical impulses of something. It can represent in real time what the electricity is doing, mostly relying on voltage. So whenever we are using this electromyograph, it's pretty much doing what the oscilloscope is doing, but with the impulses made by the muscles. So there are three ways in which these are measured. Uh, I mean, three states. It would be in rest, with a slight contraction, or a forceful contraction. So that's pretty much what the electromyograph measures. So keep in mind that it's electricity, the electricity produced by the muscle groups. And about it, these impulses are not like whenever you represent it graphically, they are not like squares as a digital signal. Since these are analog signals, they tend to look more of like a more of like sound. Whenever they represent sound, you might actually see that it's just peaks going up and down on a flat line. So that's what the waves of the electromyograph are. And also this depends completely on the action potential, which is the electricity that the muscles will need in order for them to work. This would also be explained later on with the motor neuron system. But keep in mind that these waves are produced by the electrical signals that are needed in order for muscles to work.
Well, continuing with the MGA waves, we're gonna have that. Well, in the image, we can see the normal activity of the muscle, and it's going to be represented with the voluntary contraction, with a slight contraction, like in the image of the mirror, that it's just a single motor unit signal, and with a strong contraction that will be, or it will be formed by all the motor units of the muscle. That's why we can see a little bit of not noise, but a lot of signals of these motor units of the muscle. And each blip or wave represent the firing of an action potential by a motor neuron. We're gonna have that this this machine must be calibrated to 100 microvolts in 10 milliseconds. And when we don't have electrical activity, it will just show no a line, just a line, not an impulse like in the image. But well, the theory behind this machine, this electromyograph, it's the motor neuron. And what is a motor neuron? Well, a motor neuron is a neuron that carries information from the central nervous system to the muscles through our bodies. And these, or they are specialized cells which enable us to move by relaying information from our brains to our muscles in the form of electric signals called action potentials, such as when we contract or move our muscles. And these action potentials, it's what we analyze with this machine. That's that's why it's important to know how this motor neuron functions, to see what is the this action potential in this machine or in an oscilloscope. And yeah, we're gonna have two primary types of motor neurons. The upper motor neurons that originate in a region of our brains called the motor cortex. And this one's gonna send electrical signals or action potentials to the lower motor neurons. And the lower motor neurons are attached to our muscles and act as a direct messengers to tell the muscles when to contract or when to extend. And that's the function. It depends on the magnitude of this electrical signal, and when this electrical signal is bigger or yeah bigger, we can see it in the electromyograph. Or when we don't have this electrical signal, like in a disease, we don't gonna see this action potential, then we just gonna see just a line. And that I know the MGH, no, the EMG, sorry, and the motor neurons. Well, these electrical signals are generated in the motor neurons, like I also said, and in the brain. And these signals are sent to our muscles, and these devices can measure and record in real time these signals in the monitor activity of the muscles. And with the help of the EMG, the scientists are beginning to discover new information about how movement is wired in our brain and our bodies, and how our muscles work, and how can it help to detect neuromuscular disorders. And that will be everything. Thank you.